Hello everyone, this is me, your J educator Megha, and guys, today I'm going to focus over the topic nucleophilicity versus basicity. So basically, if I write any of the species like B negative or any of the species like A negative, you will consider that yeah, it could be a base, it could be a nucleophile, but are they both same? No, guys. Base is totally different and nucleophile is totally different. And whenever we have to check the order of basicity, who is going to be a good base, who is going to be a good nucleophile, so what are the factors we have to look for? Many times students gets confused with the topic. They don't understand which is a better nucleophile, how to identify a better nucleophile. They don't understand how to identify the basic strength, how to identify that which molecule is going to be a good base, which is a poor base. So if you are struggling in the topic, then please guys go through this video. It could be of 40-45 minutes, but please go through the complete session so that you get a clear idea what we are going to discuss. What I want to tell you, it is very simple topic. Okay, once you will watch the video, everything will get very clear. You need not to revise again and again. It's just that one time if you do this, yeah, the things will be clear to all of you. Okay, and the confusion, the reason by which you people are not able to make the questions correctly of the organic chemistry, yeah, you will be able to suffice your mistake. So here I am going to start with the topic. Those who are new for the platform and don't know about me, then guys, you please look over my profile on an academy. I am a J educator. I teach you chemistry over the Academy Plus. I am teaching there from last 5 years. I'm having a total of 7 years experience, and yes, I have mentored so many students. 7,000 students I have personally mentored over the platform. And if you would see, there are 1 million plus students, those who have learned through my courses. And yes, being specialized in organic chemistry and CSI UGC net qualified with all India rank 25, I have that confidence that I can master you in the subject. I can make you master the organic chemistry. These are the basic things that we have to focus. Okay, so the GOC, this topic seems to be very easy, very small, but yet if your concepts are not clear, you will keep struggling in every topic of organic chemistry. Okay, so that's why I have uploaded the very clear, crisp and short videos for you, so that you go through each and every point with respect to the J examination. Okay, so my videos are not only for the class 12 boards, they will make you prepare for your JEE mains and advanced paper. Okay, so guys, believe me, have faith on the lectures and just go through. Now let us talk about what is a base and what is a nucleophile. Okay, so guys, you know what does a base do? A base always looks for a H positive. A base has a tendency, please write it down what I'm making you write. The base has a tendency to attack on the electron deficient species that is H positive. So a base has a tendency to attack on the electron deficient species that is H positive. That is electron deficient H positive. What is this H positive? That is proton. So if you are having any kind of base, it will attack over the H positive. So if any of the species, if it is attacking over the electron deficient proton, if it is a proton donor, then it is said to be a base. Now what do you understand by a nucleophile? The nucleophile has a tendency, anybody would tell me, please write it in the comment section, what is nucleophile? The nucleophile has a tendency to attack where? Has a tendency to attack on the electron deficient center, which electron deficient center other than proton, means here other than proton any electron deficient will center will work. Okay, the nucleophile has a tendency to attack on the electron deficient center other than proton. So this is the most important part, that is the other than proton. So if any of the species is attacking over any electron deficient center and this positive center, this electron deficient center is other than proton, other than H positive, then it is said to be a nucleophile. Let me take an example for you. Let me take an example for you to make you understand. So here the example is, if I am having any kind of base, let's say OH negative is acting as a base. When it is acting as a base, when it is attacking over the H positive, then I will say that you OH negative, you are acting as a base. But here if I am having OH negative and this OH negative is attacking over any of the species, like here let's say I am having a carbonyl group, okay, and this OH negative is attacking over this particular carbonyl carbon, which is the electron deficient center. Because of this polar pi bond, this pi bond will be broken, there will be a heterolytic cleavage, and this is an electron deficient center. So if this O negative is attacking over any of the electron deficient center, that is this is positive and this is negative, so if it is attacking over the carbon which is other than H positive, then this is said to be a nucleophile. Then this is said to be a nucleophile. So are you getting the difference? This is also OH negative, this is also OH negative. When you will be calling your OH negative as a base, and when you will be calling your OH negative as a nucleophile. Okay, now are you getting the difference? If it is accepting a proton, it will be a base, but if it is attacking over any of the carbon with a positive charge, then it is a nucleophile. Here I can do the attack of OH negative over any other kind of species like CH3 other than carbon. Yeah, it could be other than carbon. Now if you will see this particular molecule here, this will be broken like partially negative and partially positive. So this is a nucleophile if it is attacking over this carbonyl, if it is attacking over this carbon. Okay, this can attack over the nitrogen, this can attack over the carbon, this can attack over any center, but other than H positive, it is said to be nucleophile. Okay, so I hope the point is very clear, your confusion. Now I will be telling you about the major points of differences. Okay, the major points of differences. Now let's look for the points of differences. So here, as a base, this species has an affinity for proton. This species has an affinity for proton. This has an affinity, base has an affinity for proton. Okay, that is attraction for proton. But here this nucleophile has an affinity, let me write it over there, other than proton. Okay, this has affinity for other than proton. Okay, other than proton. Now guys, you know the bases are not steric sensitive. Bases are not steric sensitive, means they will not be getting affected by whether a molecule is steric or not. Okay, they are not steric sensitive. Why I am saying that they are not steric sensitive? Guys, either they are bulky or not bulky, it is doesn't going to happen, it is not going to create any kind of any issue. Let's say here I am having a carbon with 3 methyl groups. This is also methyl, this is also methyl, and this is also methyl, and this is O negative. So what can happen here? This has to attack over the H positive. So H positive is a very small species having only one s orbital, where there is no electron, it is totally vacant. So this negative can easily attack over this H positive. Okay, so there is not steric sensitive. So bases are not steric sensitive. If they have to show the affinity for proton, it's very easy for them to attack. Okay, so they are not steric sensitive. But if we will talk about the nucleophilicity, they are steric sensitive. They are steric sensitive. Okay, why they are steric sensitive? Let me take an example. Let's say if you have taken such kind of bulky group which is having 3 methyl groups, okay, now let's say this is your nucleophile, which is a bulky nucleophile. This is a bulky nucleophile, and in this bulky nucleophile, if this is a bulky nucleophile and this has to attack over this particular carbonyl carbon, Now tell me, will this bulky nucleophile will be able to attack over this carbonyl carbon? Guys, because of the steric problem, because if you will draw its structure, it would be something like this. It would be something like this. Here, this is a trigonal planar geometry. Okay, so over the trigonal planar geometry, if this bulky molecule will try to attack here because of this steric problem here, because these are the big size molecules, the large size molecules, which can do the steric problem. So this will not be able to attack over the carbonyl carbon. Okay, so this is a poor nucleophile. Here it is a good base. Here it is said to be a good base. Here it is said to be a good base. This is said to be a good base, but here it is said to be a poor nucleophile. It is said to be a poor nucleophile. So are you getting the difference? Why they are O negative? This is the same species, but the attack over H positive is quite easy, because whether it is steric or not doesn't matter. Okay, because the species where it has to attack is very very small, has high proton, high nuclear charge. Okay, it has one s orbital, it's very close to the nucleus, but here we are having a carbonyl carbon. So the attack of this particular species over this carbonyl carbon, because of the steric problem, this will not be able to attack and go over the carbonyl center. So this will become a poor nucleophile. Are you getting? So how this factor matters a lot. Now we do have one more factor, that is they are basicity is basically gives you the thermodynamically controlled or governed reaction. Okay, so basicity, write down, basicity is thermodynamically controlled So basicity basically gives you the thermodynamically controlled reaction. Okay, so if we are getting this as a product, if there is a formation of this as a product, so this bond is going to be very very strong. Okay, because this is O negative and this is H positive, these are opposite in charges and they will be forming a very very strong bond. Okay, so this is going to be thermodynamically controlled reaction, means it will be stable over the heat and light. Okay, if you will be giving large amount of energy, this bond is not going to be broken very easily. Okay, so this is going to be a stable product. The basicity is a thermodynamically controlled reaction. So basically whatever the product we will be getting from this particular molecule is going to be thermodynamically stable, means here if we will be getting C, over the C we are having 3 methyl groups and this is going to be OH. Okay, so this product is going to be thermodynamically stable for heat and electricity. Okay, now here let me talk about the next point for the basicity. If you will compare for the basicity, the nucleophilicity. So these are the very very important points which I am discussing with you, which usually you people overlook. Okay, so nucleophilicity is the kinetically controlled or governed reaction. Kinetically controlled or governed reaction. Okay, so guys, if its kinetics is not allowing this particular species to attack over the carbonyl carbon, if the kinetics is not allowing to attack over the carbonyl carbon, will the reaction will occur? Will there be a formation of a stable product? No. So if kinetics allowed, then only the rate of reaction increases, you will be getting a stable product. If the kinetics is not allowing, if the geometry of a molecule is not allowing, then you will not be getting a stable product. Okay, so this is going to be the kinetically controlled or governed reaction. So here there is no factor of thermodynamics. If the attack is possible, you will be getting stable product. If the attack is not possible, if it is not kinetically allowed, then you will not be getting the stable product. Okay, so these are the major points of differences that we need to know about the base and a nucleophile. Okay, so now other than that, we are going to discuss about the order of basic strength and the order of nucleophilicity. Okay, now we will be learning about the relative order. If I would say, that is the trend that we could see. What is the trend that we could see in the basic strength and in the order of nucleophilicity? Okay, guys, when we are having the donor atoms as same, I have also taken few of the examples which I would be discussing them with you. Okay, You people also be writing these examples in your notebook so that you will learn it in a better way. So here my first case which I have taken for you is case number 1, when the donor atoms are same. Okay, donor atoms are same. You can see that in every question I have taken O negative, O negative, O negative. This is also O negative, this is also O negative. So all are oxygen, 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 oxygen. Okay, so if they have to give the electron, so they are the same atoms. In every question I am having O negative, O negative, O negative, O negative, O negative. So ultimately these are the same donor atoms when the donor atoms are same. If you will see the example number 2, example number 1, in the example number 2, here the donor atom is a carbon. This is also a carbon, this is also a carbon. So basically the nature of the atom is same. Same, carbon, carbon, carbon is going to attack, okay, is going to be a base or a nucleophile. Now, we have to see that actually what happens when we look for their basicity and the nucleophilicity. Let's look over. So, what I want to tell you. So, when the donor atoms are same, then order of basicity, that is the basic strength, the order of basicity will be is equals to the order of nucleophilicity. What does this mean? What does this mean? This simply means that whatever be the order of basicity is going to be the order of nucleophilicity. Okay, let me take an example and let me make you understand this thing. Okay, so here if you will see in this particular question, let's talk about the basic strength. Okay, so here every species has to accept the proton. They have to accept the proton for a molecule to be basicity. They have to accept the proton. Okay, so who will accept the proton faster? If you will see the basic strength, then you will find that here in this particular case, if you will see this particular case, what you will find? You will find that here the CH3 and CH2, they are causing a plus I effect. So because of the plus I effect, the electron density is increasing. Okay, over the oxygen atom, there is the electron density is increasing, and hence it is becoming a good base. If you will see here in the option number B, you will find that this O negative is undergoing delocalization. Okay, so ultimately this is the delocalized pair of electron. So it is going to be a poor base. Okay, we can say that here we are having a minus, minus M effect of the benzene. Okay, minus M effect or the minus R effect, you can say that. Okay, minus M effect, or you can say that minus R effect with a benzene. Okay, because the electrons are not available, they are getting delocalized over the benzene ring. So delocalization is over the carbon. Okay, now here if you would see that here also this negative charge is basically getting delocalized over the sulfonyl carbon, over the sulfonyl group. Okay, that is the, we have a resonance here. We have a resonance, we are having a resonance, we can say that the negative charge is getting resonance stabilized. Okay, so this is also a resonance stabilized species. Okay, we can say that here also we are having a minus R effector. Okay, now here if you will see, here also you will find that we are having a minus R effector. Here also we can see that there is a resonance, it is also resonance stabilized. Now here this is HO negative. Okay, no other species is there, hydrogen is simply a reference atom. Okay, which we could see. Okay, now if you will compare the all the species, you will find that in the A there is a plus I effect, rather than that minus M, minus R or minus R. Okay, or you can say minus M or minus R, whatever you say. Okay, so basically they are having the resonance stabilized, resonance stabilized, resonance stabilized, but there is nothing but there is plus I effect. So simply we can say that if I have to give the order of basicity, you can say that order of basicity, you can say that A is going to be a stronger base than E. Why? Because in the case of A, you are having a plus I effect. Okay, the electron density is increasing. Now in the case of E, there is nothing, it's a reference atom. This is resonance stabilized, resonance stabilized, resonance stabilized. Okay, but if you would see, there is not much minus R effect. Okay, if I would see here, there is not very much minus R effect. the minus R effect is not very much. Why? Because here also we are having a resonance, but the resonance is over the oxygen and the carbon. Okay, so it is less stabilized over the carbon. The resonance is over the oxygen and carbon, so it is less stabilized. Less stabilized means it's a good base. Okay, so after this I can say that B is going to be more basic. Okay, because it is less resonance stabilized. If after B you will see, we can say that D is the right answer. You know, you please keep writing me in the comment section what do you think, what should be the answer. Okay, and then cross check your reasoning with me. Okay, then if you will see in the D, there is again a resonance, delocalization, and the delocalization is over the oxygen and oxygen. So the negative charge is very stabilized over the oxygen and oxygen atom. So that's why the basicity decreases. And if you will see here, the minus I effect, here we are having two sulfonyl groups. So there are two minus R with this oxygen as well, with this oxygen as well. Cross conjugation, both the oxygens we have. So ultimately here if you would see, then C is going to be the poorest base. So if I will see the order of basicity, it is going to be this as the order. Okay, that is A, E, B, D, C. If this is the order of basicity, then as per the case which I told you, when the donor atoms are same, then the order of basicity is equals to order of nucleophilicity. So ultimately we can say that if the order of basicity is same, then the order of nucleophilicity is also be the order of nucleophilicity is also be the same. Okay, because the donor atom is same. So ultimately, and there is no steric problem. We know that nucleophiles are steric sensitive, but there is no steric problem. There is nothing like that. Okay, we have no bulky group. So ultimately we can say that the order of nucleophilicity is also B is equals to A. Then we would be having for the E, then again for the B, then it is for the D, then it is for the C. Okay, I hope you got the point what I want to make it. Okay, the order of basicity is equals to order of nucleophilicity. So both the orders are same. Okay, now if we have to do the example number 2, in the example number 2, is there any steric problem? No, there is no steric problem. There is no bulkiness in any of the group. Ultimately, what do you have to focus? That which is going to be a good base. How to identify all our carbons? How will you identify? We can say that this is a carbon which is sp2 hybridized. Okay, if you will see the hybridization, this is the sp2 hybridized carbon, this is the sp3 hybridized carbon, and this is the sp hybridized carbon. Okay, and if you will see the hybridization, that is sp3, sp2 and sp. So here we are having 25% s character. Here we are having 33.33% S character, and here we are having 50% S character. Okay, so what we notice, as the S character increases, the electronegativity increases. As the percentage of S character increases, the electronegativity increases. Do you know about it? Electronegativity increases. So if the electronegativity increases, means here in the case of sp we have maximum percentage of s character. So this is strongly electronegative. So negative charge gets stabilized over the electronegative atom. Okay, so ultimately it is going to be a poor base. Okay, so when the electronegativity increases, the basic character decreases. You know about it. Electronegativity increases, acidic character increases, but basic character decreases. Okay, so here we are having 50% S character, means it is highly electronegative. This is strongly electronegative, and if it is strongly electronegative, as the electronegativity increases, okay, the basic strength, that is the basicity decreases. So it is going to be the poorest base. So if I have to give the order, what it would be? The smallest S character I can see in the case of sp3. So I would say that order of basicity is going to be, B is going to be a stronger base, then because it has only 25% S character. Then after B, it is going to be A. It has 33.33% S character. Less S character means more basic. Less S character means less electronegativity. Less electronegativity means more basic strength. Okay. Then after comes your C. So this is your order of basicity. So if the donor atoms are same, then the order of basicity is equals to order of nucleophilicity. Yeah, because again the same atom has to attack. Okay, and there is no steric problem. Then definitely whether they have to attack over the H positive or they have to attack over the other than H positive, it is going to form a same order. Okay, whether you attack them over any of the carbonyl center or any of the other center other than H positive. So here we can say that order of nucleophilicity is also going to be B, A and then C. Is it clear? Okay, so this is the thing that you people need to understand. Now let us move forward, and here I am having a very important case. In this important case, if I ask you, bache, what is the order of basicity? Then what is your answer? Write it in the comment section fast. Order of basicity. What do you think? A, B, C. We are having 3 molecules. You will simply say, ma'am, here we are having plus I due to this particular methyl group. Here we are having this. There are 2 groups which are causing the plus I effect, the plus I effect. Ultimately, they are increasing the plus I effect. And here also we can say that there is no plus I actually. Okay, you can say that there is no plus I. If we will be writing, there are only hydrogens now. So hydrogens basically can show the hyperconjugation rather than the inductive effect. Here you will say that there it is highly electron density is increasing. How the electron density is increasing? Because of the plus I effect of these methyl groups. This is also causing plus I and plus I. So if because of the plus I effect the electron density is increasing, then simply you people say, ma'am, the basic strength will increase. Right? If I ask you the order of basicity, your answer would be the answer would goes like C, and then after you will say the B, and then after you will say A. Right? So this would be the order that you will give me. That is, the order of basicity is going to be C, B and A. Why? Because here this is increasing. Because of the plus I effect, the electron density is increasing over the oxygen atom, and hence it's becoming a good donor. It will accept the proton much easily. Okay. Now my question is the order of nucleophilicity is the same? Order of nucleophilicity. Let's find it out. Guys, this question is quite smart. How? It's a smart question. Actually, here we are having a bulky group. Can you see that this is a 3-degree methoxide ion, means here we are having 3 methyl groups. So all these methyl groups are making this molecule a bulkier molecule, and because of this bulkiness, this O negative will not be able to attack over any of such a carbonyl center. If we will be having such carbonyl center, it will become very difficult for any of such species to attack over any atom other than H positive. Okay, because they are bulky, they will be having the steric problem. So we know that nucleophiles are steric sensitive. So because here we are having a case of steric sensitiveness, that is steric problem, then what we could say, this C can never be a good nucleophile. Okay, this attack is difficult. So if this attack is difficult, we can say that this is a poor nucleophile. Okay, so C is going to become a we can say that C is going to become a poor nucleophile. Here the order will decrease, the order will go reverse. Okay, C is going to become a poor nucleophile because of the steric problem. Then B will be better, and the A is going to be the best nucleophile. Are you getting? So why the order got reversed? Absolutely, A is going to be a better nucleophile. Absolutely, because there is no bulkiness. It will be very easy for this methoxide ion to attack, and that's how the ether formation occurs. Okay, so here the order gets reversed. So please mark it. This is a very very important case. If you have to attack over any of the carbonyl carbon, then please don't do the attack of such kind of a species which is very bulky. Do the attack of this methoxide. So here you people fail in the paper when such kind of thing you have to think of. Okay, so here the order got reversed. Order gets reversed. Got it? Got it? You will expect that the order of nucleophilicity should also be C has to be greater than B is greater than A, but no, this is wrong. This is wrong and this is correct. Okay, I hope you understood this very very important point relative to the basicity and the nucleophilicity. So all understood. So when the donor atoms are same, usually the order of basicity is equals to the order of nucleophilicity in majority of the cases. Okay, but you do have a case like this, then you have to be a bit careful. Okay, when there is a steric problem, then you have to be a bit careful. Chaliye. Now let's move ahead and I will be telling you about when the donor atoms is not same. Then what will happen when the donor atoms will not same? Just like I have taken few examples for you. We have O negative, here we have sulfur, here we have selenium. So these are the different atoms who are going to act as a base. Okay, those who are going to give the electron to the H positive or any other atom other than H positive. Is it? So ultimately if this is O negative, S negative, Se negative, this is O negative, S negative. I do have more examples like CH3 negative, NH2 negative, O negative, F negative. So all these are different atoms. Here the negative charge is being carried by the carbon, this is being carried by the nitrogen, carried by the oxygen, carried by the fluorine. So these are the different donor atoms. So when the donor atoms is not same, then how to identify which is a better base or better nucleophile? Let's move ahead. Okay, quite simple. I will give you an exercise after all this, and then after doing all this exercise it becomes very easy for you. So now please let's learn. Ultimately you are going to hit the J mains paper and as well as the J advance. So those who are very serious for the studies, definitely you please go through the topic. When the donor atom is not same, then in simple words, this is the case number 2. I can say that what I would say, any guesses? Order of basicity will not be is equals to order of nucleophilicity. Yes. You might be thinking that every time it is going to be the same, but no. Order of basicity is not is equals to the order of nucleophilicity. Why? Because species to be as a base, okay, has to form a strong bond with H positive. So if I am having O negative, if I am having S negative, if I am having Se negative, so this is a small size atom, the size increases, this size increases. Okay, so as we go down the group, the size increases. So who will form a strong bond with the H positive? H positive, H positive, H positive. So if this is a small size species, this is a big size species, and this is much bigger. Now you tell me, if they have to accept the H positive, then who will be forming a strong bond? Who will be a good proton acceptor? Then how will you answer? You will simply say that this O negative, here we are having a 2p orbital, here we are having a 1s orbital, here we are having a 3p, here we are having a 4p orbital. Okay, so here the OH bond is going to be a stronger bond rather than the SH bond, rather than the SEH bond. So ultimately here I can say that the bond becomes weaker. Let me write it again. This is going to be SH, the bond length increases, and this is going to be SEH, the bond length increases. So bond becomes weaker. This bond can be broken anytime. So this is the strongest bond. Okay, so if you will look for the basicity, what you would say, that any of the species that accepts the proton strongly and form a strong bond is going to be a good base. So for you, So for you, for the order of basicity, you will say that O negative is going to be a better base than the S negative because it will accept the proton strongly than the Se negative. Is it or not? Okay, so this is the order of basicity. But what will be the order of nucleophilicity? Nucleophilicity. How we can understand the order of nucleophilicity? Let me talk about it here. Okay, which is actually not is equals to the order of basicity. When we are talking about the order of nucleophilicity, okay, let me tell you. So nucleophilicity is basically the polarizability. Okay, you know that nucleophiles have to attack over other than H positive. They have to attack over other than H positive. Okay, so if their polarizability increases, if the polarizability increases, the nucleophilicity increases. So basically polarizability is directly proportional to nucleophilicity. Nucleophilicity. So I hope you know that what is polarizability. So as per the Fazan's rule, as the electron cloud of an anion increases, let's say I am having an anion, and if the electron cloud increases, let's say this is F negative, this is Cl negative, this is Br negative, and this is I negative. So if their electron cloud increases, okay, this is chlorine and this is fluorine. Okay, so if the electron cloud increases, they will be able to polarize the cation easily. They will be having a better polarizability for the cation. So if they have to attack over carbonyl carbon, and if their electrons are loosely held, their electron cloud is more dispersed or more diffused. So if their electron cloud is more diffused, okay, more diffused, they will be having better polarizability. They have better tendency to form a covalent bond, because ultimately they have to attack over any other atom other than H positive. So they have better polarizability. Okay, so electron cloud is more diffuse, better polarizability. So here, as the electron gets loosely held by the number of shells, it becomes a good donor. Okay, so here we can say that the polarizability increases, the nucleophilicity increases. So this is the point that I would want to make. Okay, so here they have to look for that with H positive they will be able to form strong bond or not. Here they have to see whether okay they will be able to attack or not. So if you will see in the example of OSSE, okay, this is the example I have taken for the fluorine, chlorine, bromine and iodine. But if you will take the example for O negative, for S negative, for Se negative, then definitely we know that it is bigger in size as compared to this and as compared to this. So this selenium is having a better polarizability. So because of the reason this has a better polarizability, it is going to selenium is going to be a better nucleophile than the sulfide and then the oxide. So this is your order of nucleophilicity. Order of nucleophilicity. And if you will find the comparison in between the two, you will find that they are just opposite in nature. Okay, so here this was the order of basicity. Now you people will say, ma'am, if the size increases, will not be the bulkiness. No, this is the tendency. Because if the electron cloud is tightly held by the nucleus, they will not be able to give now. Then how to identify the nucleophilicity power? Okay, so ultimately the aim is they have to give the electron pair to the electron deficient center. So they can only give the electron to the electron deficient center when their electrons are loosely held by the nucleus. Then only it is possible. I hope the point is clear. Okay, so this is the order of basicity, this is the order of nucleophilicity. Okay, so if I ask you an answer for the given question, what it would be? Ro negative, Rs negative, Rse negative. So order of basicity is equals to, basicity means if you have to form a bond with the proton with the H positive, who will form a strong bond? Oh, because 2p and 1s will form a strong bond. Okay, because here in the case of H positive, it's very clear that H is 1s orbital. H is 1s orbital. Okay, so here the answer will be A is going to be better base, then B, and then C. If you know any of the answer, you can easily understand that the order of nucleophilicity is going to be the opposite. Order of nucleophilicity is going to be just opposite, is not same. So opposite means what? Here C is going to be a better nucleophile, then B, then A. Okay, just opposite. Okay, now if we are having the another example like this, here what is the comparison that we can make? Of course, both are resonance stabilized, but still, because sulfur is a large size atom, here the electron cloud is loosely held, but here over the oxygen, which is an electronegative atom, the negative charge will get strongly stabilized, and hence the what will happen? We can say that this is a better base. This is a better base because ultimately it is going to form a strong bond with the hydrogen. But here, because of the large size atom, the polarizability is high. We can say that this is a better nucleophile. This is a better nucleophile. So this will win the case of a nucleophilicity. This will win the case of a basicity. Are you getting it? Because in the case of a base, we have to form a bond with the H positive, and in the case of nucleophile, we have to give the electron pair. It has to be a better anion, better polarizability it has to be. Okay. So I hope all these points are very clear to all of you. Now let's move forward. Here I am having a very important case for you. Okay, so when the donor atoms are not same, it is going to be opposite. है ना? Basicity and nucleophilicity are not going to be the same, they are going to be opposite. But what happens if we have such a case, that is CH3 negative, NH2 negative, OH negative, F negative? Now what we can do? Think of it and tell me. Now guys, you know what? This is also a 2p orbital. 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 They all are 2p, 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 2p. So if you will look for the polarizability, the number of shells are same ultimately. There is no matter of size. There is no variations because the number of shell is only second shell. It is not going to happen that they are having so many number of shells and so therefore the size increases, electron becomes loosely held. Okay, so there is no such case. Okay, so please write it down. If donor atoms belongs to the same period, okay, same period means same shell, same period, okay, then same shell, then order of nucleophilicity is equals to the order of basicity. The order of nucleophilicity is equals to the order of basicity. Okay. Now guys, here when we always looks for from left to right, okay, when we always looks from left to right, let me tell you, along the period, electronegativity factor dominates. Electronegativity factor dominates. Okay, because they will be having a marginal difference in their electronegativity values as per the Pauling scale. But as we talk about top to bottom, along the group, which factor dominates? Along the group, the size factor dominates. Size factor dominates. Okay, so please keep in mind this happens along the period or along the group. Along the period or along the group. Okay, this is what you need to know. So here, if I take this particular question, they all are having the 2p, 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 2p orbitals. Now, who will be having a better nucleophilicity? If I have to give the order for the nucleophilicity, order of nucleophilicity, then my answer would be CH3 negative is going to be a good nucleophile, then NH2 negative, then OH negative, then F negative. Why? Why? Because it is less electronegative. Ultimately, here this fluorine is very electronegative. Very electronegative. That's why it will hold the electrons more tightly. It will hold the electrons, it will hold the electrons more tightly, and will not be a good donor. Tightly, and will be a poor donor, and will be a poor donor. Okay, so why? What is the reason? The reason is electronegativity. So if it is very electronegative, if it is very electronegative, then it will hold the electrons more tightly and will be a poor donor. Okay, so poor donor to what? To any deficient center other than H positive. That's why we are saying that fluorine is going to be a poor nucleophile. Now, if you have to give the order for the basicity, so what I just said, here I have given you this particular point. This is a note for you all. Okay, this is a very important case. So here the order of basicity is going to be the same. What it is going to be? The same. That is, CH3 negative is going to be a good base. The same reason, then the NH2 negative, then the OH negative, then the F negative. Why the same reason? Because the thing is, if CH negative will accept the proton, this will form a stable bond. Okay, but F negative, it will not even try to give the electron to the H positive. No, yeah, they all are 2p, 2p, 2p. So 2p 1s bond is going to be the same. Okay, the strength is not going to be a much difference. Okay, the bond length is going to be the same. But the point is, the carbon, which is less electronegative, will easily give the electron pair to the H positive rather than the F negative. Okay, so as the electronegativity increases, the basicity and the nucleophilicity decreases. Okay, got it? So we know that, please understand, if the electronegativity increases, the basic character decreases, and even the nucleophilicity also decreases. The polarizability also decreases, becomes the size becomes smaller. Okay, so when the size becomes smaller, fluorine is highly electronegative atom, it will hold the electrons very tightly. So ultimately, if it will hold the electron very tightly, they will not be able to give the electron pair. Ultimately, the basic strength decreases and the nucleophilicity also decreases. Understood? So these are the things which I discussed with you. If you want to take a recap, please have a look. Bases, those who accept H positive. Bases are those who accept H positive, and the nucleophiles are those accepts the other than H positive. Okay, here I told you the most important point. Bases are not steric sensitive, but the nucleophiles are actually steric sensitive. So whenever you have a steric problem, you have to think about it again. Basicity is the basicity. Whenever we talk about the base, when it accepts the H positive, this is a thermodynamically, it has to be a strong bond formation. This is a thermodynamically controlled reaction, but here the nucleophilicity is the kinetically controlled or governed reaction. Okay, so here I have given you the example for this. Then I have taken two cases. When the donor atoms are same, basicity is equals to nucleophilicity. Okay, and the another case, when the donor atoms are not same, then the basicity is not is equals to the nucleophilicity. If you know any one of those, you can answer the other one. Okay, they are not same, so every time we cannot say that the order of base is equals to order of nucleophile. No. Okay, donor atoms are same, they are going to be the same. Donor atoms are not same, they are not going to be the same. So when the donor atom is same, so ultimately the bond formation, the number of orbital taking part in the bond formation, the period group is not going to make any difference. Okay, ultimately oh, it's the same element, same period, same group. Okay, everything is same. So ultimately we will first focus over the basic strength. So if you are getting this as the order for the basic strength, this will be the order for the nucleophilicity. Then again, this is the example which I have taken. But here there was an important case of the steric wala. Okay, so if there is a steric problem, then ultimately base will form. This will be a good base. C is going to be a good base. But for the nucleophile, because of the steric problem, C is going to be a poor nucleophile. Got it? Now, when the donor atoms are not same, the order is going to be opposite. So what you can do is, you people focus over the nucleophilicity. My take is, look for nucleophilicity. Nucleophilicity means more polarizability. Bigger be the size. Okay, just a minute. Bigger be the size. Electrons are loosely held. It will be able to give the electron very easily. So more polarizability, more nucleophilicity. Okay, so here we take that O negative, S negative, Se negative. It's a bigger nucleophile. It's a bigger nucleophile than this, than this. So ultimately, C is going to be a better nucleophile. Okay, so this is a take for nucleophilicity. And we know that the basicity order is going to be opposite. Okay, what is the reason? Reasoning, I told you, because if they have to form a bond with the H positive, so it has to be thermodynamically stable. Got it? No? Bases are thermodynamically stable. So if they are forming a strong bond with the hydrogen, then yes, it is going to be stable, otherwise not. So that's how A will form a strong bond with the hydrogen, which is thermodynamically stable, because 2p1s overlap is a good overlap. Okay, the same thing I discussed there. Okay, now the next important case which I have taken is when the different donor atoms belongs to the same period. So when the donor atoms, if donor atoms belongs to the same period, okay, these are the different donor atoms. If different donor atoms, यहाँ लिख लो, if different donor atoms belongs to the same period, then the order of nucleophilicity and basicity becomes the same. Reason being, they are in the same orbital, the nucleophilicity, because along the group the size factor dominates, but they are in the same period. So ultimately they all have 2p, 2p, 2p orbitals. Okay, they have the same shell, all are having n is equals to 2. So ultimately the electronegativity factor, here we have to look for the electronegativity factor. So as the electronegativity increases, the basicity or the nucleophilicity both decreases. Okay, because the electronegativity increases, you know that the basic character decreases, and at the same time the nucleophilicity, because if the electron cloud will get tightly held by the nucleus, here I told you, if the electron cloud will get more tightly held by the nucleus, then definitely they will become a poor donor. Their polarizability decreases, their nucleophilicity decreases. Okay, so both will decrease. Okay, so that's why we got that here the order is going to be the same, whether it is basicity or nucleophilicity. Now, here are a few questions for you all, and I would like you people to answer all of them. Okay, so let's begin with it. I hope you are ready. Please keep writing your answers in the comment section. Keep writing, bache. SiH3 negative, PH2 negative, SH negative, Cl negative. If you will see, they all belongs to period number 3rd. Yeah, they belongs to same period. Period number 3rd, case number 2. They are different donor atoms. Different donor atoms. So for the different donor atoms, the order of nucleophilicity will same or not? Different donor atom. Think about it. Different donor atom. If the donor atoms are different and they belongs to the same period, this was a special case. So here the order of nucleophilicity and basicity is going to be the same. If you will look for nucleophilicity, absolutely. On which factor it depends? It depends upon electronegativity. Electronegativity increases, basicity decreases, nucleophilicity also decreases. Okay. So ultimately I can say that SiH3 negative is a good nucleophile, then PH2 negative, then SH negative, then Cl negative. Similarly for the basicity, SiH3 negative will form a strong bond with the H positive, then the PH2 negative, then the SH negative, then the Cl negative. Got it? Different donor atoms but belongs to the same period. So we have to focus over the electronegativity factor. Got it? Now here we are having FCl, BRI. Donor atoms different. different donor atom. So when different donor atoms, but they are along the group top to bottom. So top to bottom, what happens? The basicity and nucleophilicity are not same. They are not same. So different donor atoms. So what will be the order of nucleophilicity? For the nucleophilicity, it has to be a big size atom. It has to be a good nucleophile. So I can say that I negative, you are going to be a good nucleophile, then the Br negative, then the Cl negative, and then the F negative. And if you will see the order of basicity, who will form a strong bond with the H positive? Okay, because now we will be having different orbitals. Here we will be having n is equals to 2, n is equals to 3, n is equals to 4, n is equals to 5. So there will be a strong bond formation with the fluorine. So we can say that order of basicity is opposite. Now F negative is going to be a strong base, then the Cl negative, then the Br negative, and then the I negative. Got it? So this is going to be the order. So this and this is totally opposite. Okay, so this is what we would say. Okay, so or you, if you want to write it in another way, you can write it this way. Okay, if you want to write it the other way, increase decrease sign, if you want to change, you want to write it as I negative is a poor base, then Br negative, then Cl negative, then F negative. Anyway, you can write. Okay, it's totally your choice. Okay, the way you want to write. So basically, F negative is a strong base. Now let's come to the another example. OH negative, SH negative. Again, they are different donor atoms. Different donor. So when the donors are different, then definitely the order is not going to be the same. So now this is OH negative and SH negative. Different groups, O and S. S is going to be bigger. So we know that SH negative is going to be a good nucleophile than OH negative because of the bigger size, high polarizability, and the order is not going to be the same. So ultimately, who will form a strong bond with the OH negative? OH negative is a stronger base than the SH negative. When we have the another question, which is RO negative, RS negative, R is the electron pushing group, electron density will increase because of the R plus I effect. Now this is O and this is S, different donor. So for the different donor, we know that the order is not same. Order is not same. If the order is not same and it is going to be opposite, what it would be? We know that again, S is a large size species. It is going to be a good nucleophile. For the nucleophilicity, we have to see the size. So RS negative is going to be a good nucleophile than the RO negative. Now for the basicity, it will become opposite. RS negative is going to be a poor base as compared to that of the RO negative. Why? Because RO negative will form a strong bond with H, that is the alcohol will form. Okay, RO negative or this. Now we have the another example. This is RO negative, this is HO negative. Now here this is also O negative, O negative. Means same donor atoms. So when we have same donor, what we understand? The order will remain the same. They we will be having the same order. So ultimately, what will be the order of basicity and nucleophilicity? Here we are having the plus I effect. There is a electron pushing group, but there is the hydrogen, which is a reference atom. So I can say that RO negative is a good nucleophile than HO negative. But here for the basicity also it will remain the same. I can say that RO negative is again a good base than HO negative because the donor atoms are same. Got my point? Now here this is O negative, this is O. Donor atoms are same. Okay, same donor. So a same donor, for the same donor, and there is no steric wala problem now. So same donor, the order is going to be the same. So here rather than HO negative, and here the oxygen with a lone pair, which is a good donor. Guys, always negative is a good donor because here in the case of HO negative wants to neutralize itself by giving the electron pair. Okay, so here we would say that HO negative is a better nucleophile rather than H2O. Okay, so for the base as well, HO negative will react with the H positive at the fastest rate to become neutralized to form water rather than the H2O. Always negative is a better nucleophile than the lone pair. Here we have the negative charge and here we have the lone pair. Again the same donor atom, and for the same donor atom we know whatever be the order of basicity is going to be the order of nucleophilicity. Okay, so what was that? This is a negative, this is a lone pair. Of course negative wala is going to be a good nucleophile than the lone pair. Okay, because it will get neutralized by attacking over any of the deficient center, so the reactivity increases as compared to this is going to be the same. Okay, now we have the last example. Here let me write A B C D. Okay, A B C D. If you will compare all the four, O negative, O negative, O negative, O negative means we are having the same donor, and when the donor is same, the order is same. Is there any steric problem? No, there is no steric problem. Ultimately what you can focus is, we can see that here we are having plus I effect, here we are having minus R, here we are also having minus R, and here we are having so much of minus R. Ultimately I can see that the RO negative is going to be a good, the both the orders are going to be the same. RO negative, because of the plus I effect, is going to be a good donor, will give the electron density very easily. So ultimately the order will be D is going to be a better nucleophile than the C. Why C? Because here we are having resonance, but the resonance is over the carbon, benzene carbon. Okay, so when this negative charge undergo delocalization, it will get delocalized over the carbon, which is will not be stabilized. Okay, that's why it's C. And after C, here it is getting delocalized over oxygen. So then after it becomes B, and then after it becomes A. Why? Because in the A we have 2 minus R. Delocalization will be here as well and will be here as well. So this is A. A will go at the last. So this is the order of nucleophilicity, and definitely the same is going to be the order of basicity. Yes, they are not bulky. They are not bulky. Okay, so here we can see that A could be bulky, but yeah, we are putting A at the last, so it's fine. If in the case of A there is a steric problem, so yeah, its nucleophilicity is poor, so it's fine. Okay, so because of the bulkiness as well and because of the steric problem as well. Sorry, because of the steric problem as well and because of the minus R as well. Double minus R. And here we are also having the fluorine, which is a very showing very strong minus I effect. Becomes the poorest nucleophile or the poorest base. Again, the same order will be here. D, then after C, then after B, and then after A. Same. This is it, guys. I hope now you won't do any such kind of mistake that you will keep doing while solving the questions of organic chemistry. So if you are at any stage of your preparation, I'm not talking about if you're learning GOC only, then only you go through this particular topic. If you have done the complete organic chemistry and while doing the questions you are struggling with the questions, then also you need to go through this particular session. This is a very deep down the concept that you pupil sometimes try to guess or sometimes just put the reasons illogically. So please don't do that. Okay, at least learn this once, and then if you have any doubt, any query comes up in your mind, do let me know. I am there to help you out, guys. Okay, so here, thank you so much. Please do like, subscribe and share this session if it helps you anyway, any pattern, if this has helped you. Do follow me on Unacademy, as there are many number of courses that we people are taking. A group of best educators are teaching you over the platform. So what are you waiting for? Move ahead and do follow me on Unacademy. Guys, I am also a CSI UGC NET qualified with All India rank 25. I have completed my studies from Delhi University, and being being specialized in organic chemistry, I can help you deep down with this topic. Okay, so organic chemistry means if you do it completely, do it thoroughly, otherwise don't do. Okay, so basically it's a very very good saying for the organic chemistry that half done is not done. ओके सो इफ़ यू आर डूइंग समथिंग, अच्छा ठीक है इतना मैंने कर लिया, इतना मैंने हो जाएगा करके, इफ़ यू आर डूइंग योर प्रिपरेशन, देन yeah, organic will not going to give you marks. Okay, rather than getting the positive marks, you will end up getting the negative marks. I'm not here to demoralize you. I'm just saying try to cover up each and everything. Okay, if you will focus, then definitely you have high chances to score 99 percentile itself in chemistry. Out of all those 25 questions, you can easily get 23 or 24 questions correctly done. Yes, organic will give you this much of good number. Okay, so please guys, see you soon. Thank you so much for today's lecture. This is all about now, and I would be happy to help you. If you have any doubt, please do let me know. And if you really like today's session, then please hit like, share, comment below. Okay, I need to listen from you. Please write it down, whatever comes to your mind, either it is positive or negative, just please put it in the comment section. Okay, so this is it for today. See you later. Bye bye, take care.